Hello, my name is Sharon Pruitt. For this analysis, I am examining whether there is a statistically significant difference in district enrollment among Region 1, Region 2, and Region 5. The research question guiding this analysis is there a statistically significant difference in district enrollment among Region 1, Region 2, and Region 5? The null hypothesis states that there is no difference in mean enrollment across the three regions. The alternative hypothesis states that at least one region differs in mean enrollment. In this video, I will review the normality assumption, homogeneity of variance, interpret the general model, univariate analysis, explain the ANOVA table, interpret effect size using eta squared, and finally discuss post hoc comparisons using Tukey and Sidak. This is the data set that we will be using. Before running the ANOVA, I evaluated the assumption of normality for each group separately, Region 1, Region 2, and Region 5. I assessed normality using histograms with a normal curve overlay, which is appropriate given the moderate to large sample sizes for regions 1 and 2. In order to do this, you go to Data, select Cases, click on Region. If condition is satisfied, click If, and I've already gotten regions 1 and 2, so we're needing region 5. I click Continue, OK. Now I go to Analyze, Descriptive Statistics, Frequencies. We want to make sure our enroll variable is in the variables box. Click on Charts, Histograms, Show Normal Curve on Histograms, Continue. OK. Region 1, N is equal to 72. It shows a right-skewed distribution with some extreme values. However, ANOVA is robust to moderate departures from normality, especially with larger sample sizes, such as Region 1. Region 2, N is equal to 66. We see it also demonstrates slight skewness, but generally follows a unimodal pattern consistent with approximate normality. In Region 5, N is equal to 23. Region 5 has a smaller sample size and more variability. However, the distribution does not show severe violations that would prohibit proceeding with ANOVA. Overall, the normality assumption is adequately met for the purpose of this analysis. Next, I evaluated homogeneity, a variance assumption using Levene's test of equality of error variances. I computed the homogeneity of a variance test by using the general linear model. You go to Data, select Cases, click on Region. If condition is satisfied, click If, and we want to highlight each region. Region 1 or region equals 2 or region equals 5. So I have each of my three regions represented. Click Continue. OK. Now go to Analyze, General Linear Model, Univariate. We want to make sure enroll is in the dependent variables box, region is in the fixed factors box. We click on Options, click Estimates of Effect Size, Homogeneity Test. Continue. Okay. The univariate analysis of variance is here, but we want to first take a look at Levene's test of equality of error variances. Based on the mean, note in the mean row, Levene's statistic is 8.126, taking into account degrees of freedom 1, which is 2, and degrees of freedom 2, 158. F is equal to 8.126. Sig is less than 0.001, indicating that the variances across regions 1, 2, and 5 are not equal. However, if we look at the median row based on median, when this Levene's test is based on the median and adjusted degrees of freedom, the p-values are greater than 0.05, suggesting more stability when accounting for non-normality. Because ANOVA is relatively robust to violations of homogeneity, particularly with reasonably balanced group sizes, I proceeded with the analysis, interpreting results cautiously and emphasizing size of effect size. The general linear model, also called the univariate analysis, provides the omnibus test of group differences. We look at the test of between subjects effects. Let's look at the region row. The effect of region on enrollment produced an F statistic of 2.957 with a p-value of 0.055. Because the p-value is greater than 0.05, this result is not statistically significant. Therefore, I failed to reject the null hypothesis. This indicates that there is no statistically significant difference in mean enrollment among regions 1, 2, and 5 at the 0.05 level. The ANOVA table presents the same test in a traditional ANOVA format, separating variability into between group and within group components. To assess the ANOVA table, you go to Analyze, Compare Means and Proportions, and click on One-Way ANOVA. Enroll goes into the dependent list, region goes into the factor list. I want to assess my post hoc test, the Tukey and the Sidak here, so I can click on post hoc, then continue. If I looked at options, I would get homogeneity of variance test and the Welch's test. So I'll go on and click on those again and click continue. Okay. Now, the ANOVA table takes into account between groups and within groups components. Between groups represents variability due to differences among the regions, whereas within groups represents variability within region. F and SIG values are listed, and the F value is 2.957 with a P value of 0.055. Both the univariate test and the ANOVA table led to the same conclusion. Statistical significance does not tell us how meaningful the difference is, so I also examine effect size. The eta squared value is 0.036, meaning that approximately 3.6% of the variance in district enrollment is explained by region. According to conventional guidelines, this represents a small effect size, suggesting that region accounts for only a small portion of enrollment variability. Although the omnibus ANOVA was not statistically significant, I examined Tukey's HSD, which is the post hoc test required by my professor. Noting the SIG column, all Tukey comparisons between regions 1, 2, and 5 have p-values greater than 0.05. This indicates that no individual pair of regions differ significantly in mean enrollment. Additionally, all confidence intervals include 0, further supporting the absence of statistically significant differences. As a supplemental analysis, I also ran Sidak post hoc tests, which are more conservative when sample sizes are unequal. The Sidak results are consistent with Tukey's findings, with all the p-values remaining above 0.05. This consistency strengthens confidence in the overall conclusion. In conclusion, after evaluating a normality, homogeneity of variance, the general linear model, ANOVA table, effect size, and post hoc comparisons, there's no statistically significant difference in district enrollment among regions 1, 2, and 5. The ANOVA result was marginal but not statistically significant. F with degrees of freedom of 2 and 158 equals 2.957 here. 2.957 and a p-value of 0.055 with a small effect size of 0.036. Both Tukey and Sidak post hoc tests confirmed that no pairwise differences were statistically significant. Therefore, the null hypothesis is retained, and region does not meaningfully explain differences in district enrollment in this sample. This concludes my video.